Before starting the next lesson, try this warm-up. What type of function are these? So I have two different relations, two different functions represented by two different tables of value. So for the first one, what type of function is it? Linear, quadratic, exponential? Same with the second one. What is it? See if you can remember how to figure this out. So pause the video, try it, and you can check back in to see how you do. If you'll recall from previous grades, you can try the first differences. So for here, from 15 to 11, I'm going down 4. From 11 to 7, I'm going down 4. From 7 to 3, down 4. From 3 to -1, you're going down 4. So the first differences in this case are all the same, which means this is a linear function. If I do the first differences for this function, though, well, I'm going down 8, then down 4, then down 2, then down 1. The first differences are not all the same. I could try the second differences, but they would not all be the same either. So here I'd be going up 4, up 2, up 1. They're not the same, so it's not quadratic. So I'm going to try the ratios of the first differences. So this gets multiplied by a half, this gets multiplied by a half, this gets multiplied by a half. So you're multiplying by the same number every time, which means this is an exponential function. So that was just a recap of how do you know what type of function you have if you're only given a table of values. But this unit is about exponential functions. So in this lesson, we're going to look at the properties of exponential functions. So I'm going to start by giving you some terminology that you can use, and we're going to finish with an investigation. So the whole goal of this is for you to be able to identify the properties of an exponential function and explain or prove why some of those properties exist. So let's start with the general equation for an exponential function. Here I have it in function notation. So f of x is just a generic label for a generic function, a function of x. This part here, a times b to the exponent x, that is the general form that all of our exponential functions are going to take. A is the coefficient, b is the base of the power, and the exponent is your independent variable, whatever that is that you're measuring. So this is the format that all of our exponential functions are going to be written in, a times b to the exponent x. So let's just start with some basic terminology when we're looking at functions. The point where a graph crosses the x-axis, that's the x-intercept, and the point where a graph crosses the y-axis is called the y-intercept. An exponential function is said to be increasing if its general shape looks like this. So as you move from left to right through the function, it trends upwards. That's called an increasing exponential function. If it's the opposite, if as you read the graph from left to right, the graph decreases, we call that a decreasing function. Now, every time you graph an exponential function, you're going to notice that they have this same general shape, but I've drawn it here as a blue dotted line. There's going to be a certain value that your function will never equal to. It'll get really close, but it won't ever get equal to that value. So this line that a graph approaches but never touches or crosses has a name, and it's called the asymptote. Hopefully this is all stuff that you know and remember from previous grades. If not, here it is for you. And that should get you started for the investigation. So work through the investigation and hopefully you can come up with the correct conclusions. And if you get stuck or get confused, just reach out and I'll do my best to help.